Welcome to Mastering Tech Insights. Today we will discuss on PyTorch fundamental. In the next few videos, you are going to build your first model using PyTorch. Let's cut straight to the point. Why are you actually here? PyTorch powered most modern AI research. Companies actively demand it, and yes, it is one of the earliest way to build any model systems. But none of that is the real reason PyTorch Won. Let me show you with a dead simple example. Suppose we want to add two numbers and print the result. In PyTorch, the code looks like this. That's it. If you have never heard the word Tensor, did not panic. A tensor is just a Python way of holding numbers like list but optimized for maths. The important points: it feels like normal Python, it behaves like normal Python, and you immediately see the output. Why this matter? You might think, so what? This code looks regular code. Exactly. Deep learning used to be nothing like regular coding. Imagine you are building a recommended systems. Traditional programming, you write the rules. If the user buy a camera, recommend lenses. If it's gift, the rule breaks. If they already owned lenses, the rules break again. You end up write thousands of expressions and you are still missing half of them. Machine learning flips everything. You give the system examples of inputs and outputs. It learns the rule for you. Deep learning takes this even further. Natural networks learns directly from data. Cat photos, it's learn what a cat looks like. Purchase history, it's learns pattern. Humans cannot write rules for. But earlier frameworks were a nightmare. The problem: natural networks require insane amount of maths. Every single example triggers a massive chain of calculations. Multiply that by thousands or millions of examples. Every frameworks were not built for humans. They were built to survive the computational choices. This made even simple tasks like adding two numbers looks like this. You could not directly print the result. You got weird graph, but instead of value, everything felt rigid and unnatural. Static computational graphs explained, like those old frameworks use static computational graphs. Think of it like a factory assembly lines. You must design every steps on front. Once built, you cannot insert a new steps in the middle. If something wrongs, you must tear the whole graphs down and rebuild. The worst scenario, you could not test small part of your model. You could not use normal Python, if or for loops. Inputs had to be fixed size only. Error message pointed to internal system code, not your code. It was rigid and so to experiment with and extremely painful to debug. But the birth of PyTorch comes with the strong philosophy. Deep learning should behave like normal Pythons. It introduced dynamic computations. Write normal Python's code. PyTorch build the graphs on the fly. Want to add a steps, edit. Want to use loop or in if statement, use them. Wants to debug, you can stop executions and inspect everything instantly. Your code stay readable. Your error point to your line numbers. Your development speed skyrockets. This changes everything. Why PyTorch Won? PyTorch did not fix the programming experience. It built a massive ecosystem. Thousands of researchers use it. Tons of read-to-use model and solutions. Hug community supports and constant updates. Whether you are beginners or working at the cut edges, the path is already proven. Now you are ready to join that ecosystem. Whether you are here to experiment with ideas, grow in your AI career, or simply get comfortable with modern mastering tech insights, you are the right place. Let's start building PyTorch. Thank you for watching. Keep subscribe, keep follow Mastering Tech Insights.